In this tutorial, I'll show you how to model the Super Mario mushroom blender. Looking at this character, the top of the head is almost a perfect sphere, so let's begin with that. Press Shift+A to add, go to Mesh, and choose UV Sphere. To see the reference, press Alt+Z to enable X-ray. On the bottom left corner, expand the Add UV Sphere panel, then set segments to 24 and rings to 12. Now let's scale and align it with the reference. Keep in mind that snap is set to increment, so we can use Ctrl and Shift to move, scale, and rotate in steps. Holding Ctrl moves in increments of 10, while Shift plus Ctrl moves in increments of 1. Press S to scale, hold Ctrl, and scale it down to match the reference. Press G to grab, Z to lock the axis, hold Ctrl, and move it into place. Press R to rotate, hold Ctrl, and adjust until it matches the reference. For fine-tuning, hold Shift plus Ctrl to step back a bit. The final result here is a scale of 0.1, positioned at 90 mm on the Z-axis, and rotated -28 degrees. Since I'll be using the Subdivision Surface modifier, I like to add it before modeling. This way I can roughly see the final result, which helps guide the process. A quick way to add it is by pressing Ctrl plus the number of levels you want. Here I'll press Ctrl plus 2 to set the viewport subdivisions to 2. Finally, because we manipulated the object, press Ctrl plus A and apply the scale. With the UV sphere in place, let's start modeling. Press Tab to go to Edit mode, enable proportional editing, and set the size to 150 mm. Here I'll use the object's local transform orientation to help move the vertices. That is why I didn't apply the rotation. Press comma to change the orientation and set it to local. Now select the bottom vertex, press G to grab, Z to lock the axis, and move it to match the reference. Next, let's check the front view. Press O to disable proportional editing, Alt plus Z to enable X-ray, and Ctrl plus numpad plus to select more. Now press S to scale, X to lock the axis, hold Ctrl, and scale to match the reference. On the left view, press G to grab, Y to lock the axis, hold Shift plus Ctrl, and move to align with the reference. Then press S to scale, Y to lock the axis, hold Ctrl, and scale to match. Now press X to delete, and choose Faces. Here I'm going to use one of the best Blender modeling add-ons in my opinion, the Edge Flow. Go to Edit, Preferences, Get Extensions, search for Edge Flow, and install it. The Edge Flow add-on helps adjust mesh geometry to curved surfaces. To use it, select a loop you want to adjust, press Ctrl plus Z to open the Edge menu, and select Set Flow. Now I'm going to model the white dots. Select the middle vertex at the center of these circles, then press Ctrl plus numpad plus to select more. Press I to inset, type 10 for 10 mm thickness, and hit Enter to confirm. Then right-click, go to Loop Tools, and choose Circle. For this part, I'll disable the Subdivision modifier in Edit mode. Sometimes it's hard to select the edges while that option is active. For the top circle, I want to get rid of the triangle faces. Select the vertex, press Ctrl plus numpad plus to select more, then Ctrl plus F to open the face menu and choose Grid Fill. Set the offset to align the edges, then to make it brown, press Ctrl plus Z and select Set Flow. Next, let's extrude these faces to create the white dots. So let's select all the faces from these circles. Press Alt plus Z to extrude, choose Extrude Faces along normals, type 3 for 3 mm offset, and hit Enter to confirm. To round the corners, go to the Select menu, select Loops, then choose Select Boundary Loops. Press Ctrl plus B to bevel, type 3 for 3 mm width, and hit Enter to confirm. To make sure there are no overlapping vertices, press A to select all, then M to merge by distance. Now let's create support loops on these dots. Select all false circle edge loops, press Ctrl plus B to bevel, and type 0.3 for 0.3 mm width. Then press numpad plus to increase segments to 2 and hit Enter to confirm. Next, let's crease the inner bevel edges. Press Ctrl plus numpad minus to select less, then Shift plus Z to crease, type 1, and hit Enter. Since the top face loop between the dots is flat, let's subdivide it. Press Ctrl plus R to create a loop cut, and hit Enter twice to confirm. Press S to scale slightly, then press G twice to slide the vertices into place. Here I'll use set flow on the loops above and below the dots. This isn't strictly necessary, but I think it gives a better final result. With both loops selected, press Ctrl plus C to open the Edge menu and choose Set Flow. To finish this part, let's add a mirror modifier. But before that, we need to fix the vertical loop that isn't straight anymore. A simple way to fix is to select the loop, press period for pivot point, and set it to 3D cursor. Then press S to scale, X to lock the axis, type 0, and hit Enter. Enable X-ray, select half of the mesh, press X to delete, and choose Faces. On Modifiers, add Modifier, Generate, add a Mirror modifier, and place it above the Subdivision modifier. Now I'm going to model the face. Select the bottom loop, press Ctrl plus I to invert the selection, and H to hide in the viewport. This leaves us with only the loop we need visible. For this part, I'll use vertex extrusion to model. Select the front vertex, press E to extrude, drag it to follow the reference, and left click to confirm. Now keep repeating this until you have created 11 vertices. When that's done, shift select the back vertex and press F to create a new edge. Now we have an edge loop with 12 edges outlining the reference image. At this point, I like to select the loop, right click, go to Loop Tools and choose Space. This spaces the vertices evenly along the loop. Next, let's extrude the loop to create faces. But instead of extruding the whole loop, I'll select these bottom 10 edges. On the front view, press E to extrude, X to lock the axis, and align it with this vertex. Now we'll need to scale the loop to follow the reference. But before scaling, let's set the transform pivot point. Press period for pivot point and choose bounding box center. Now press S to scale and adjust until it matches the top vertices and the reference image. Now repeat these steps a couple times. Extrude along the x-axis to align, then scale down to match the top vertices and the reference image. Extrude along the x-axis to align, then scale down to match the top vertices and the reference image. Now let's create the side faces. Select these two vertices and press F to create a new edge. Press Ctrl plus R to add a loop cut and hit Enter to confirm. Then on the front view, press G to grab, X to lock the axis, and move it slightly outside the reference image. Now we need to match the curvature and the vertex count with this top loop. Press Shift plus Ctrl plus B for vertex bevel and drag to follow the curve. Now press numpad plus to increase the segments to match the top loop and hit Enter to confirm. To refine, press Ctrl plus numpad plus to select more, right click, go to Loop Tools and choose Space. Repeat these steps once more. Create a new edge, subdivide it, drag it outside the reference, bevel to follow the curve, then space to refine. Now we have enough geometry to fill the faces. Select an edge, press F to create a new face, and keep pressing F until all faces are filled. Select an edge, press F to create a new face, and keep pressing F until all faces are filled. For the top section, select 4 vertices and press F to create a new face. Then select an edge and continue pressing F until the section is complete. With face orientation enabled, you'll notice the top faces have different orientation than the rest, and disabling X-ray confirms this. The default color means the normals are pointing outside, while red means they are pointing inside. To fix it, press A to select all faces, then Shift plus N to recalculate normals. Now I'll arrange the vertices to make the loops more organic. Instead of dragging each vertex manually, let's use the Edge Flow add-on. Start with the loop crossing the eyes. Press Ctrl plus E and set flow. Next, adjust the two corner loops. Press Ctrl+Z and set flow. Then the loop between those corners. Press Ctrl+Z and set flow. Finally, the other two corner loops. Press Ctrl+Z and set flow. To add more geometry for the eyes, press Ctrl+R to create a loop cut. Then select this loop, press Ctrl+Z and set flow again. To finish, let's create a support loop between the face and the top of the head. Press Alt+H to unhide all mesh faces, select the loop, press Ctrl+B to bevel, and type 1 for a 1mm width. Now press numpad plus to increase segments to 2 and hit enter to confirm. Now crease the inner bevel edges. Press Ctrl plus numpad minus to select less, then Shift+Z to crease, type 1 and hit enter to confirm. Now refine the mesh to better match the reference image. I'll speed up this part, then return to model the eyes. Make sure the subdivision modifier is enabled in edit mode so you can see the final result. Here I'll select the edges and vertices, then drag them to align with the reference. You can also enable proportional editing and use the edge flow add-on to make this step easier. After refining the mesh, let's create the eyes. Press 3 on the keyboard to enable face selection and select the 3 faces in this area. Press I to inset, type 2 for a 2mm thickness and hit enter to confirm. Now press E to extrude, type 4 for 4mm and hit enter. To round the corners, press F3 to open the menu search and choose Select Boundary Loops. Then press Ctrl+B to bevel, type 4 for 4mm width and hit enter to confirm. Since the extrusion bevel were the same size, this creates overlapping vertices. To fix it, press A to select all, then M to merge by distance. Now let's create a support loop between the eyes and the face. Press Ctrl+B to bevel, type 0.5 for 0.5mm width and hit enter to confirm. Next, crease the inner bevel edges. Press Ctrl plus numpad minus to select less, then Shift+Z to crease, type 1 and hit enter to confirm. Since I've creased all the edge loops between each part, let's mark them as seams. This will make it easier to select each island. With the crease edges selected, press Shift+G to select similar and choose crease. Then press Ctrl+Z to open the edge menu and select Mark Seam. The modeling is complete, so press Tab to exit edit mode. Now we just need to set the shading, rename the object, apply the mirror modifier, and reset the origin point. To set shading, right-click and choose Shade Smooth. To rename, press F2 and call it Mushroom. To apply the modifier, hover the mouse over it and press Ctrl+A. Finally, to reset the origin point, open the Object menu, go to Set Origin and choose Origin to 3D Cursor. The mesh is complete, so we can move to the Shading Workspace to create the materials. Here I'll create a base material, then duplicate it to make the others, one for each mushroom color. Click New to add a new material and rename it Dots. Now let's add some nodes to build this material. Press Shift+A to add a Voronoi texture node. Now let's zoom the viewport a bit to better see the result. With the Node Wrangler add-on enabled, hold Shift+Ctrl and left-click the Voronoi to preview. To make the texture smaller, set the scale to around 200. The Voronoi effect is too strong, so let's fix it. Press Shift+A to add a mixed color node and place it over this noodle chain here. Set the blending mode to multiply, the factor to 0.1 and place the Voronoi on color B. Now let's add another mixed color node to blend this with the mushroom color. With the node selected, press Shift+G to duplicate it and place it over this noodle chain here. Set the factor to 1 and choose the color for the dots in color B. For mine, I use the hex code FF, FF, FF. With most of the nodes ready, select the principal shader and place it at the end of the chain. This connects everything to the base color. To add detail, let's set the roughness and normal. For roughness, connect the first mixed color node's result to the principal shader's roughness input. For normal, drag the same result into empty space to open the search menu. Search for bump and choose bump height to add a bump node. Now connect the bump's normal to the principal shader's normal input, enable invert to invert the Voronoi effect, and set the strength to 0.25. The base material is complete. We just need to duplicate it, rename, and change the base color. Click to add a new material slot, browse materials, and select dots. The dots material is now on both slots and we need to unlink it. Click the tool icon to make it a single user copy and rename it color. Now we can set the base color for this material. So let's set color B to a bright red. For mine, I use the hex code FF3333. Add another slot, browse materials, and select color. Click the tool icon again, rename it skin, and set color B to a skin tone. For mine, I use the hex code FFAF8C. Add one more slot, create a new material, and rename it eyes. Set the base color to black, and reduce roughness to 0.1 for a shinier look. Now let's assign the materials to the mesh. Press Tab to go to Edit mode and enable face selection. Since we marked seams, it's super easy to select each island. Click a face to ensure nothing else is selected, then press L to select the island. Then choose the corresponding material from the list and click Assign. Now repeat these steps. Select the island, choose the material, and assign it. Then repeat once more. Select the island, choose the material, and assign it. Finally, press Tab to exit edit mode. This completes the shading, and this is the final result. If you found this tutorial helpful, don't forget to give it a like. It really helps the channel grow and let me know you enjoy this kind of content. And if you want more Blender tutorials and 3D projects, make sure to subscribe and hit the bell icon. Thanks for watching, and I'll see you on the next one.